quickly because of the time given to us. So I have to rush. And
okay, now thank you very much. I get your point. The time not enough, right? Okay, I get your point. Thank you very much. I will take it.
I couldn't upload that too.
But can you solve all the questions? Adola Jikon.
Not all, sir.
Okay, you cannot solve all the questions. Okay, thank you very much for the feedback. Okay, who else again that would like to speak? Awa. Awa Gaba, please speak.
Yes, sir. Good evening, sir.
Good evening. How was the test?
Yeah, we thank God, sir. I was really trying to upload. I cannot upload, and the time was really small. So I said, let me upload one.
We started the test around 4:12.
Yes,
and I stopped it around 5. So I think you guys spent more than 45 or 50 minutes. So what is the problem?
Yes,
5 questions, 50 minutes.
I was trying to upload, sir, especially the audio. I don't even know where to go. You say we should go to our file manager. I went there, I named the file, but I don't know where to take the file to the e-learn.
Thank you very much. Thank you very much. Thank you very much. Thank you very much. I can get your point now. Thank you very much. Now, Idris, Musa Abud Idris, you can speak. Musa Abud Idris, you can speak. Okay, you can speak now. Hello, Musa Abud Idris, you can speak. Okay, while we're waiting for you. Sulaiman. Ask your notes. Okay, okay. Then who would like to speak now? Can you hear me clearly?
Hello, sir.
You are speak. I can hear you clearly now.
Yes, I actually waited for the test. I think since 12 o'clock, I have prepared myself so much waiting for the test. The moment you send the test, I think 10 minutes past 4.
Yes.
I launch into it. I attempt the questions, but now sending it becomes a problem to me, because when I tried to upload it, it was not going. I tried to tell my file is too large. I should snap it. I screenshot it. I send it.
But point of correction, I told you that we're starting the test by 4 o'clock.
Yes, sir.
So why are you waiting for me since 12 o'clock?
No, your question, I mean, since 12 o'clock, I've been, I think, going through the video, preparing for the test.
Okay.
Yes,
but can you solve all the questions?
Yes, I solved not all, but I solved some good ones that I think.
What about question number 1? What about question 1? Can you solve question number 1? Are you able to solve question number 1?
The question I attempt is question 5, 4, and 2.
Okay, thank you very much.
I didn't go for question. Yes, sir.
Okay, thank you very much. Yeah. Now, real one, Tayo, you can speak. Real one, Tayo, you can speak.
Good evening, sir.
Good evening.
Good evening, sir.
How was the test?
Sir, it was okay. It was fun. I really enjoyed it, sir.
Yes, exactly. Thank you very much for the feedback. Okay. So are you able to solve all the questions?
I had issue with number 1 because I'm unable to upload that particular number 1, but 1 to 2 to 5, I was unable to upload those ones.
Okay, so, thank you very much.
Yes, sir.
Thank you very much. I will do something about that. Thank you. Who else again? Oh yeah, Sulaiman Mohammed Abu Bakar. I can hear you. Oh, yeah. Sulaiman Abu Mohammed. Oh, yeah, speak. Oh, yeah, speak. I can hear you.
Sir.
Oh, yeah, speak.
Good afternoon, sir.
Good afternoon, Sulaiman.
I take time and watch all the videos, but the problem is that. Hello?
I can hear you clearly. Please speak.
Hello, sir.
I can hear you clearly. Please speak.
Hello?
I can hear you. You can go ahead. Go ahead, please. Speak, okay?
I take time and watch all the videos, sir.
Okay.
But the problem is that. Hello?
I can hear you. Continue. Continue, please.
Hello, sir.
Sulaiman, I can hear you clearly. Oh no. Okay. Okay, thank you everyone. So can you all hear me now? Hello, can you all hear me?
Yes, sir.
sir.
Okay, let's start today's class. So today we are going to focus on exacts. You can remember that I've sent the video to you, but I would like to speak on it before we proceed with today's class. So can you all see my screen now? Can you all see my screen?
Yes, sir.
Okay, thank you very much. So let's proceed. So in today's class, we're going to focus on exacts. And if you remember vividly, I've said something about exacts, but let me introduce to you. The first thing is that everybody look at equation 1. If you look at this equation 1, you notice that we can easily separate the variables, isn't it?
Yes,
now,
sir.
if we can easily
Yes, sir.
separate the variables, then let's just rearrange to make x the y to stand on this left-hand side. And we have minus y ds the other side. So by the time we do all those things, we integrate. I think all of us, you can see clearly now that this is the solution. Equation 2 is the solution. Do you all agree?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, now the problem is this. If you look at this very, you will notice that you will notice that we can say function fx comma y is equals to a, which is a is a constant of integration. Do you all agree?
Yes, sir.
Now,
Yes,
if
sir.
you look at this equation 2 very well, you notice that we have been able to solve equation 1 to give us equation 2. And what does that mean? It means that there is a function, and that function is the solution of equation 1, and that function is equals to constants. Do you all get my point?
Yes,
Do you
sir.
all get my point? Let me say it again now. We've been able to solve equation 1. And when we solve equation 1, we obtain equation 2 as a solution. And the solution we have here, we can say function fx comma y is equals to yx, y times x, which is equals to a, which is the solution. Now, before we proceed, now let me now interpret that to you. Look at slide 2 now. If that is the case, there's something called total differential in mathematics. Total differential is telling us about change in a particular function with respect to two variables. So what I'm trying to say now is that if my z is equal to f, look at this expression now. You know, this z is same thing as, z is same thing as f. Are we together?
Yes, sir.
So if z
Yes,
is
sir.
same thing as f, then what is the change in the solution across the domain? That is why I emphasize on xy plane here. Can you all see what I say? I said where fx comma y is xy is a constant a, but note that our z is a constant. And if z is a constant, then it means that the function is continuous in the domain xy plane. That's what I'm trying to say there now. But look at it very well now. If you differentiate z and z is a constant, what will you get? If you
Zero.
differentiate constant, what will you get?
Zero.
Zero. So we get zero. That is how I obtain this expression, which is the last thing here now. Now, let me take you to the next slide now. Now, let's take a look at this interpretation now. What am I trying to say is that, what I'm trying to say now is that if we have this expression, we have this expression, and the expression is mx comma y dx plus nx comma y dy, then we can say that is equal. Now, if you look at this expression, we notice that this side is equal to 0, isn't it?
0, yes, sir.
Yes. And this total differential is also what? 0. So if this one is 0 and this one is 0, then which means that this one is equal to this, isn't it?
Yes, sir.
That is a fundamental principle now. Now, what is the next thing is that if you match using the method of superposition now, you notice that m here is same thing as what? Partial f, partial x, isn't it? If you look at n here is equal to what? Partial f, partial y. Can you all see there?
Yes.
Okay, this is what we are going to use to solve the problem now. But before we use this one to solve the problem, let us try to differentiate both sides. Let us differentiate this one with respect to y. If we differentiate this one with y, we now have partial m partial y is equal to partial y, then partial f partial x. Now this one again, let us differentiate both sides of this one with respect to x. So what are we going to get? We get partial n partial x is equal to partial square f partial x partial y. So what does it mean? It means that the second derivative, they are equal, isn't it? So if the second derivative is equal, then what does that mean? It means that the problem is actually what? Is actually exact. So now let's now try to define it now. Look at this definition now. When do we say a differential equation is exact? Look at what we're going to do now. Look at the step 1 now. What is the step 1? You take your ms comma y. What's ms comma y here? ms comma y is what?
S square y cube.
Y square.
Now,
Y
what of ns comma y?
X cube Y
S
square.
cube y square.
That is the most special. Okay. Then the next thing is this: we find partial n partial y. What is partial n partial y? You know, in this case,
3x square y square.
that will, you know, here you are trying to differentiate with respect to y only. You know, we call it partial derivative. I think you remember, and that should be maybe in 100 level, partial derivative. Yes. So in this case, if you are to differentiate with respect to y, you focus only on y. So 3 will come down, then you subtract 1 from the power of y. Then that will give us y squared. Then what is partial n partial x? That will give me what? You know, here I will need to focus on x. That will give me 3x squared, then y squared. Now look at it very well. In this case, we now see now that partial n partial y is the same thing as what? Partial n partial x. So what does that mean? It means that the differential equation is what? Is exact.
Exact.
So any question on this before we proceed, please ask me any question. Any question on this before I proceed? Any question on this? Hello, please, everybody speak. Let me proceed now. I think all of us will understand what we mean by exact differential equation now.
Yeah.
Hello, sir.
Oh, yeah.
Hello, sir.
Okay, what's the question? Balogun Said, you can speak.
Okay. Yes. I don't have any question.
Thank you very much. But if I may
hello,
ask
sir.
You, hello, I can hear you clearly. Where speak?
As in this, when you are doing the partial differentiation,
okay,
this m of x comma y, and then n of x comma y. What about if maybe I now decide to differentiate x instead of y in the m?
You will make a mistake. Don't forget that m is a multiplier of dx.
Okay.
And you are to differentiate m with respect to y. You cannot differentiate with respect to the coefficient again. And in this case, n is the coefficient of dy. So you have to differentiate n with respect to x.
Okay.
So,
noted.
Noted. Thank you very much. Let's proceed now. Now, let's take a look at this criterion now. Let's take a look at this criterion. In this criterion, you will see that in this criterion, you will notice that when do we now say we have exact? There are 3 keywords here. Number 1, we first of all get the coefficient of dx, which is m. We get the coefficient of dy, which is n, isn't it? Then the next thing is this. We talk about the continuity of the two variable function m and n. So we now know that m is continuous, n is also what? Continuous. And don't forget, you know, I've said it before, that continuity is not a complete statement. We said that a function is continuous at a point. So there's need for us to specify the domain of continuity. So that is why in this case, we are now saying that m and n, they are continuous in the interval of a and b, in the interval of c and d. So we can now say that if that is the case, then we can now say that if partial n partial y is equal to partial n partial x, then we can conclude that the differential equation is what? Is exact. So let's take a step now. Let's solve this example now. Everybody, now let's look at this example together. Are we all together?
Yes, sir.
Oh yeah, let's take a look. Let's take a look at this problem now. We want to solve this problem. 2xy dx plus x squared minus 1 dy is equal to 0. Now in this case, what is my mx comma y? Don't forget, mx comma is the coefficient of dx. So what is mx comma y?
2xy.
2xy.
Now what is
ns
ns comma y? That is correct. What is ns comma y now?
X square minus 1.
Minus 1.
So let's go to the second step now. What is the partial derivative of m with respect to y?
2x.
And what is the partial derivative of n with respect to x?
2x.
2x.
So what does that mean now? What does that mean? It means that the differential equation is
equal.
Exact.
It's exact. So it means that differential equation is what? Is exact. Now let's proceed now. If it is exact, then we can go ahead to solve the problem. But if it's not exact, there's another thing we need to do. In today's class, I will show you an example of a differential equation that is not exact. and I will show you how to solve it, and you will like the method of solution. Now, look at the first step now. We said partial S is equals to M. Do you remember the genesis of this expression? Let me show you the genesis of the expression. Look at this expression. Look at this. If you look at this expression now, what is ms comma y? Ms comma y is what?
The f over the x.
No, that's wrong. You said partial f.
Partial f over partial x.
Partial x.
F partial f over partial.
Now, let's go back now. Look at the first step now. The first step now is this. We start from partial f, partial is equals to m. And what is my m? 2xy. You know, I can cross multiply. The partial s can come to this side, isn't it?
Yes, sir.
Then what is the next thing now? I will integrate.
Integrate.
If you integrate both sides, you know, this time you are integrating with respect to x. You know, we are only having partial x, so you have to integrate with respect to x. Now, how do we integrate with respect to x now? Everybody, let's look at it now. If you integrate partial f, what will you get? You have f. Now, if you integrate 2xy, what will you get?
2x y squared plus c.
No.
Okay, x squared y plus c.
You know, that will give you 2x squared
y
multiplied by y divided by what?
2.
By 2.
Divided by 2. So divide by 2, we cancel 2, then you have this one.
2, yes,
then
sir.
what about the constant of integration? You know, in this case, how do we integrate partial derivative now? Partial function. You know, here we are integrating with respect to what? With respect to x. So what would be the constant of integration? You know, in this case, we integrated with respect to x. Why we said our y is what? Our y is what? Our y is constant. So because we say our y is a constant, then the constant of integration will now be g of y. Hello, are you hearing me? Are you all with me? You know that 2 is a constant, isn't it? 2 is a constant, isn't it?
Yes.
Yes.
And 2 is a constant function, because I can say 2 multiplied by y raised to power 0, isn't it? So if I can say 2 times y raised to power 0, that means that 2 is a constant. So in this case now, so because we are integrating with respect to x, our constant of integration will be a function, and the function will be depending on y. Why is it y? Because we say y is a constant. Are we together now? So the next thing we are going to do now is this. Looking at this expression, we are going to differentiate both sides with respect to y. Don't forget the first step. The first step is partial f, partial s is equals to m. Then you integrate, you have your f. Then the next thing is this, you will now differentiate f partially. I'm talking about partial derivative with respect to y. Now, what is the next thing now? Let us differentiate both sides with respect to y. So we now have partial f, partial y is equals to, if we differentiate x squared y with respect to y, what are we going to get?
X squared.
Okay, you know that will give us x squared, then multiplied by y, then y is what? 1 minus 1, isn't it?
Yes.
So 1 minus 1 is what is 0, and anything to 0 is what is 1. So that is how we obtain our x squared here. Now, if you differentiate g with respect to y, what we have? You have partial g partial. Hello, if you differentiate g with respect to y, you have partial g partial what? Partial y.
Right.
Now, do you know something? Let me scroll up. Look at this expression again. Look at this expression. Look at it now. What is partial f, partial y? Partial f, partial y is what?
N F comma y.
So can you now see clearly now? So that is the reason why, if you get back to this place, you need to equate your partial f, partial y to be equals to n. Are we all together now? Are we all together?
Yes.
So that is why I write, that's why you see x squared minus y here, because partial f, partial y is equals to n. So by the time you differentiate both sides with respect to y, you need to equate the answer to n. Now, look at the next thing I'm going to do now is that I will focus on this. Now, if I focus on this, you will now see that I'm having x squared plus partial g partial y is equals to x squared minus 1. So what is the next thing now is that our x squared can go to the other side. So if x squared should go to the other side, you now see that we're having x squared minus 1, then minus x squared. Then x squared will cancel x squared, then you have minus 1. Then what is the next step now is that we are going to integrate both sides. if you integrate both sides, what you have is what is minus y. So the last step now is that we now substitute our g back to this expression. I'm talking about this expression. Are we all there? So we are going to substitute our g to this one. So we can now say that our fx comma y is equal to what? X squared y, then minus y. So don't forget that in the first example, I said the function fx comma y is equal to what? Constant. Let me scroll up and show you. Look at this expression. Can you all see there? Look at this place, equation 2. Y of x is equal to what? Constant a, isn't it? So now that we've obtained our fx comma y, we will now say that our fx comma y is equals to constant c, which is the solution. Okay. So I believe by now, everybody, we can solve exacts. Yeah. So now let me now show you another problem. Oh yeah, please ask your question. What's your question?
So you differentiated 2x and x squared and y to get x squared. How come? Even if the partial
you will differentiate partially.
That's
partial derivative. Partial
of
derivative.
X squared.
Yes. Now let
me
respect
to y should give you 2x now instead of x squared.
No, look at it. You are having y. Let me share my screen with you so that you can all see my screen. You need to partial derivative. Okay. Let me share my screen with you. Okay. Now, can you all see my screen now? Can you all see my screen now?
Yes, sir.
Oh yeah. Now, someone asked me a question now on this. Look at this expression now. I'm trying to integrate. Oh, I cannot. I'm okay. Okay. Can you all see my screen now?
Yes, sir.
Yes, sir. So look at this place now. Look at this expression now. We have this expression. We have this expression. Then you are integrating. You are trying to differentiate both sides partially. So if you are to differentiate both sides partially, you will now see that one will give you. I don't like this PowerPoint. Okay. Okay. Now you can now see clearly. I'm having. Okay. So look at this now. This is what I'm having now. So if you do this one now, can you see what I've just done? Can you see it now?
Yes.
Partial derivative of both sides. Look at in this case, you know you are differentiating this one with respect to y. And this one is y raised to power 1.
Yes.
So y raised to power 1. So if you have to differentiate this one, what we have? This one will give you 1 minus 1. Isn't it? So,
yes, sir.
And 1 minus 1 will give you 0. Anything to 0 is what is 1. So that's how we obtain that.
1.
Is there any question again?
No, sir.
Okay, I think I've been able to answer that question. So let's proceed now. So we are going to consider another thing in this class. Okay. Okay. So the next thing we are going to consider now is the case of non-exact. Let me mute everyone. Okay, so let's proceed now. Let me see so that you can see my screen. Let me share my screen with you. Where is it? Okay. Okay, can you all see my screen now? Please signify. Can you see my screen clearly? Can you all see my screen?
Sir. Yes, sir. Yes, sir.
Okay, thank you very much. Let's look at this now. This is the case of non-exact now. Let's look at equation 1 very well. Do you know that equation 1 we can rearrange it to make it look like this one will stand here, then x, y, dx will go to the other side. Then it will become minus x, y, dx. Now, if you divide both sides by dx, you have dy dx. Then you divide both sides by 2x squared plus 3y squared minus 20, then you have this one. Now, if you look at this now, you will now see that this is the problem we are trying to solve. Can we all see it clearly? Now, in this case now, if you see any problem like this, please, I would advise you to try this method I want to introduce to you now. Because even if it is exact, then fine. If it is not exact, that is also good. Now, let's proceed down. What is our fx comma y here? What is mx comma y here?
XY.
XY. Then what is
XY.
N? What is N?
2 square, 2x square plus 3y
squared minus 20.
20. Then what is partial N, partial Y?
X.
What is partial N, partial X?
4x.
Can we say equation 1 is exact?
No, sir.
Now, that is the problem now. Equation 1 is not exact because partial N, partial Y is not the same thing as partial N, partial X. So how do we solve a problem like this now? Let's proceed to page number 2. Look at page number 2. Everybody, let's look at this very well. Let's focus on this. I want to explain something to you now. Let's say we have equation 1, and equation 1 is non-exact. There are two things involved. Number 1, look at number A. You find partial N, partial Y minus partial N, partial X. Then you divide by N. Now, do you know this one I'm dividing by N? Because N is the one that is carrying the negative sign. Are we together now? Are we together?
Yes, sir.
Yes, sir.
Okay. Now let me say it again. Partial N, partial Y minus partial N, partial X divided by what? N. So what is integrating factor now? Integrating factor now is that if this answer here will give us a function depending on X alone. What I'm trying to say that by the time you find your partial Y, partial N, partial Y, you subtract it for partial N, partial X, then you divide the answer by N. If everything you are having there is a function on X, then your integrating factor will now be exponential integral partial N, partial Y minus partial N, partial, then dx. You know, I'm integrating with respect to X because the function is depending on X alone. If this one is not work, if this one will not give me exacting in the sense that if this number 1 will give me a function that is not depending on X alone. For instance, by the time I do this one and I get something like a function, inside that function, I can see X, I can see Y. That means that option A is not advisable. I need to go for option B. Now let's look at option B now. In the case of option B now, I will differentiate N with respect to X minus, I will differentiate M with respect to Y, then I will divide by M. If this one will give me a function that is only depending on Y, then it means that the integrating factor is now exponential integral nx minus my divided by m, then it will now be dy. Are we together now?
Yes, sir.
It will now be dy. But in the first case, if it's depending on only x, it will be dx. Are we together?
Yes, sir.
Yes.
Before I continue, I want someone to raise up and I want someone to explain this. Looking at these two, I want someone to speak on these two because that's just the only technicality aspect of non-exact. Someone should please raise up and if you understand what I've just explained, please. Someone should please signify. Someone should please signify if you understand what I just explained to you. Ayani Adetong, are you there with me? So
yes,
please,
sir.
Do you understand what I've just explained?
Yes, sir.
Okay, would you like to speak? Please explain to others. Let's see the way you understand.
For the case 1, sir, you said if it is dependent on only x, we make use of the value of my minus nx divided by n.
Okay.
But for the other,
no, you didn't finish it. You didn't finish it. You didn't finish the statement too. You know, if my minus nx divided by n, if it will give us a function and that function there is x, only x, we have only x is the function. Then integrating factor will now be with respect to dx. You will integrate the function with respect to x. I mean, you integrate with do you get that?
Yes, sir.
Now, someone should please, someone should speak on number 2. I need another volunteer. Let me look for someone else to speak on number 2. Balogun Said.
Yeah, if
read one.
x,
oh yeah, speak.
If x nx minus my is equal to m is a function of y alone, and then if it depends on y alone, that means that we integrate it by square exponential integral nx minus my divided by m dy. So we can't use it.
Thank you very much. Now, let me now explain to you now. What we are trying to do is that we are looking for a way to make a function that is not exact to be exact. Let me say it again. A function that is not exact, we want to make it to be exact. So the only thing we need now is that we need integrating factor. When we get the integrating factor, it will help us to make that function that is not exact to be exact. Now let's look at example 1 now. Let's go back to the example 1 now. Example 1, look at this problem. I think you all remember this problem. Do you all remember this problem? But look at the problem very well. Now, if you look at this problem, you will see that the prime is not exact, isn't it?
Yes, sir.
Because
Yes,
my is not the same thing as nx. I'm trying to say that partial n partial y is not the same thing as partial n partial x. So what do we do now? Let's look for it. I know I can conclude that the prime is what is non-exact.
exact.
So we now want to make it to be exact. What do we need to make it to be exact is that we look for integrating factor. Now let's look at the first step now. Look at the first step I introduced to you. In this case, my is x, nx is 4x. So here I'm now having x minus 4x divided by n. In this case, you will notice that here I'm having a function depending on x and y, isn't it?
Yes.
Yes, sir.
So I cannot use this first one. I can't use it because it will not give me what I'm looking for. If I should use this number 1, it will not be able to make a non-exact to be exact. I can't use it, so I have to reject it. So let's go to number 2 now. Number 2 is nx minus my divided by m. Now, what is this 4x minus x? 4x minus x is what?
3x.
3x. Then what is my m? What is m?
xy.
xy.
Now, in this case, x will cancel x, isn't it?
Yes, sir.
Yes,
Then
sir.
I'm
Yes,
now
sir.
having 3 over y. You know, in this case,
Yeah.
3 over y
Yeah.
is a function depending on only y.
Y. Yeah.
So this is what I'm going to use
Yeah.
to get my integrating factor. Now, let's look at integrating factor now. Integrating factor is what? Exponential integral what? 3 over y.
E minus y.
So if you integrate 3 over y dy, what do you get? You get 3 ln y.
Y.
And you know 3 can go to be the power of y.
Yes, sir.
Then you now have
Yes, sir.
exponential ln y raised to power 3. What will happen is that exponential will cancel ln, isn't it?
Yes,
Yes,
Then
sir.
you have
Yes, sir.
y raised to power 3. Now, do you know the next thing I'm going to do now is that I will now multiply both sides of the problem of equation 1 by the integrating factor. Look at what I'm saying now.
Okay.
So you multiply both sides of equation 1 by y. That is why you can see here I said y raised to power 3 multiplied by xy dx. What I'm trying to do is that I'm trying to multiply both sides by the integrating factor. Look at this one again. I'm multiplying y raised to power 3 multiplied by nx dy, which will give me this one. Do you know the next thing is that the next thing is to expand. So what is y raised to power 3 times y? That will give me x y raised to power 4.
X y power 4.
The next thing is this: I'll multiply this one by this one again. Then this one give me 2x squared multiplied by what?
2x
y3. Then
y3
plus y raised to power 3 will multiply y
3y5.
squared. We give me y raised to power 5. Then I have 20 here. It give me 20 y raised to power what? 3.
3.
Now we are now having equation 3. Do you know the next thing I'm going to do now is that let me now check if equation 3 is now exact. In equation 3, what is ms comma y?
X y is to by 4.
Y raised to power 4.
Then what is my?
4x
squared
raised
y
to power
cubed plus 3y raised to power 5 minus 20 cubed.
You know, in this case, I'm trying to differentiate with respect to y, isn't it?
Yes, sir.
Then how do I do that? 4 will come
Yes,
down.
sir.
Then you subtract 1 from
Yes,
the
sir.
power, isn't it?
Yes,
Now
sir.
let's go to our n now. Our new n is what? 2x squared y raised to power 3, then plus 3y raised to power 5 minus 20y raised to power 3. Then what is partial n partial x?
Differentiate with respect to x.
4x y cubed.
Okay, that is correct. Now, what does that mean now? Can we now say equation 3 is exact now?
Yes, sir.
So you now see what I'm telling about now is that even if a problem is not exact, we can make it to be exact. What do we need to do? Look at the screen again. We find my minus nx over x. We now check if what we get is depending on only x. Assuming that this one is depending on only x, that is what we will use for our integrating factor.
Okay.
You know, in this case, we're having x and y here. See, the numerator, we have x. Look at the denominator, we have y squared. So definitely, I cannot use this one to get my integrating factor. It will not use it. It is not useful. So we need to ignore this. Look at the second step again. Nx minus my divided by m. What do I need to do? I will look at this. You see that in this case, the function I get is what? 3 over y. And 3 over y is a function depending on only y. So that is the reason why I go for this second one to get the integrating factor. And by the time I get the integrating factor, I'll multiply the problem that was not exact before by the integrating factor. Then it will now become exact. I think you all get the method now. So let's proceed and solve it now. Before we proceed, can you all see my screen?
Yes, sir.
Look at the first method I solved. Let me explain the procedure to you again. The first step is this. You go for partial f, partial s is equal to m, isn't it?
Yes, sir.
You
Yes,
integrate.
sir.
Yes, sir.
By the time you integrate, you have your f. What is step number 2? You differentiate with respect to what? With respect to y, isn't it?
Yes, sir.
Then what is the next thing?
Yes,
You
sir.
equate to n. Now, why do I need to equate to n? I need to equate to n because partial f, partial y is equal to n, isn't it? So by the time
Yes,
I
sir.
equate my partial f, partial y equals to n, then I can make partial g, partial y to be the subject of formula. By the time I get my partial g, partial y, I will integrate again to give me my g of y. Then I will now substitute my g of y back to fx, y. Then I will get the solution. Do you remember the method now? So
Yes,
let's
sir.
now come back now. We are back now. Let's look at equation 3. If you look at equation 3, we now want to solve it now. What is the first step? Partial f, partial s is equal to what? Is equal to
X over
and
y.
what is our m? My m is what? X, y raised by what?
X over 4.
4.
My dear students, sometimes ago I was marking the scripts of our student and the student made a mistake. Do you know the mistake the student made? Instead of using this, our new m, you know, we are having 2m now, isn't it?
Yes, sir.
Yes, sir.
1m, we get 1m that is not exact. Do you know that this 1m, this is m, x, y. The student went ahead to go and use the m that is non-exact. And the student was not able to get the correct answer. So definitely, you know what I have to do now. I will need to mark the students wrong. So please take note of that. Don't use old m. You use the new m in equation 3. Are we together now? So let's proceed.
Yes.
So partial f, partial x is equal to xy raised to power 4. What is the next thing? You multiply both sides by what? By dx, by partial x. Then you have this expression. What is the next step? You integrate both sides with respect to
Y.
with respect to x.
Okay.
But your y is a constant.
Yeah, X.
So when you integrate both sides now, you now see that this one will give me what? X 1 plus 1 over 1 plus 1. Then multiply by y raised to power 4, then plus g of y. Do you know this one I'm using g of y here? Because I integrated both sides with respect to x. Why I fixed my y to be a constant. That is the reason. That is the reason. So in this case now, my g of y is a constant of integration. Why am I writing? Why can't I write g of x? I cannot write g of x because I integrated with respect to x. Are we together now? Because I integrated both sides with respect to x. So my constant of integration will now be a function depending on what I said to be a constant. So you now see now that I'm having fx, y is equal to x squared over 2, then y of 4, then plus g of y. So this is my equation 4 now. Everybody, can you see equation 4 very well now? So what is the next step now? The next step now is that I will now, yes, speak.
If for example now we integrate with respect to y here, then our g will now be g of.
Yes, it will be g of x. It will be g of x.
Will now be g of x.
Yes, that's
okay,
how
the
to
other way
integrate.
around.
That's how to integrate function depending on two variables.
Okay.
If you have a function that is depending on two variables and you are integrating with respect to one, you will pick other to be a constant, and that constant will be a function of the constant you fixed, of the variable you fixed.
Yes, sir.
Are we together now?
Yes.
Are we together? So
Yes, sir.
now let's proceed now. What's the next thing now is that I will need to differentiate both sides partially. With respect to what? With respect to G. I mean, with respect to Y, rather.
Y.
So I will now have partial F partial Y is equals to partial Y of this function plus, if you differentiate G, you have partial G partial Y. So what's the next thing now is that I will have my partial F partial Y is equals to, if I, look at it, I want to differentiate this one with respect to Y. You know, x squared over 2 is a constant. If you go outside,
Yes, sir.
then you now differentiate Y raised to power 4. That will give you 4 minus 1 multiplied by what? Multiplied by 4. So that's why I'm having 4 Y raised to power 3, because 4 minus 1 is what is 3. Then I will have partial G partial Y. Now, what's the next step now is that I will now equate partial A partial Y is equals to what? Is equals to N. Why am I equating it? Don't forget the procedure. Let me show you the procedure again. Everybody, look at it. Can you see my screen now? Can you see my screen?
Yes, sir.
Can you see my screen? Look at it now.
Yes, sir.
You know, in this case, if you use method of superposition, you notice that NX, Y is equals to partial F partial what? Partial Y. So can you see now? So you start with N, you equate with this. So let's proceed now. So you cannot see clearly now that that is why I said that I will need to equate. There is someone that is, I think I need to mute only Musa. Is only Musa. Okay, now you cannot see now that here I equate to NS, Y. Is there any question on this again? I think you all understand how I equate, why I equate it to NS, Y. Is there any question on this?
No, sir.
Okay, so everybody, you know the reason why I said equals to NS, Y. Because partial A partial Y is equal to what? Is equal to N. Now, look at it now. Then I can focus on this side now. So what is my NS, Y? Please don't forget that we have two N's. One N for non-exact and one N for exact. So look at this N. You have to use the N that is what? That is exact. So you equate to N now. So what's the next thing now is that we now focus on this side only. So we make our partial G partial Y the subject of formula. So we now have everything here, we go to the other side. So that's why here, you know, I'm having two, this one here is A, this expression is A, this one is A, then this one will go to the other side. We now give me minus. So this one will cancel this one. Then what is my partial G partial Y now? Partial G partial Y is now what? Is now 3Y raised to power 5 minus
20 Y raised to power 3.
What's the next step now is that I will now return, I will now have this one. Do you know the next thing is that I will integrate? I will integrate both sides of equation 5 with respect to Y, because what I'm looking for is what is G. What I'm looking for is G. Look at this one, you know, here. Look at equation 4. You know, equation 4 is the solution we are looking for. But we don't know our G. That is why we proceed by differentiating both sides of F with respect to Y, so that we can equate to N, so that we can get our G. So look at this one. You cannot see now that here, function we have here is only Y. You know that there's no X there. Look at equation 5 very well. You notice that there's no X in equation 5. There's no X. So you now integrate both sides. When you integrate both sides, don't forget, how do you integrate? 3Y, 5 plus 1 over what? 5 plus 1. Then minus 20 Y, 3 plus 1 over 3 plus 1. Then you get your equation 6. What's the next thing is that we substitute equation 6 back to equation 4. Then we get our solution. That is how to solve non-exact. So any question? So now if you go and check your lecture manual, lecture material, I'm talking about your MTH232 lecture notes, that one that given to you by National Open. They are trying to solve non-exact, but if you look at the method they are using, it's very, I don't really understand that method. I don't really know how to, it's very simple, but it's so technical. So I would advise you, please go and check your lecture note again. The case of non-exact, any case you see, please use this method. Check if it is exact, then solve it. If it is non-exact, then use this method. You will see that you get all of them. So that's why I'm presenting this method to you. So this method here will help us to solve. So thank you very much. So what we now do is that concerning your test, I will go back again and make it open. But people that submitted, I will give them bonus of 33 marks. You know, I'm a lecturer and I've been dealing with students very well. So those that are able to submit, I think like 10 students, they're able to submit. I've checked 10 students submitted before so all the students that have submitted, 3 marks is even small. I will give them a bonus of 4 marks. So even if I thought they get everything, they will get the bonus of 4 marks. But those of you that you are submitting late now, I will not give you bonus. Is that okay? Is that a deal?
No, sir.
I'm telling you, that's a deal. I don't know. What's opinion? What's opinion?
It took me about 1 hour to solve it. I was just canceling.
I beg, come on, stop it. Stop it. I'm dealing with university students. Oh. Excuse me. Hello. I'm dealing with university students, not undergrad, not anyhow student, not secondary school student. Oh. So if I give you 5 questions and I give you like 45, 50 minutes, 10 minutes per question. Sorry. Sorry.
Someone was separate. I was actually on the way when you sent that question. I was coming back from church. So I was unable when I got home. I was
you know that we are starting by 4. Even that is another reason why I didn't post. I make sure that I give extra 10 minutes. I posted the question around 4:11. So you know say that you don't have any excuse. So so those that have submitted, let me even show you my screen so that I can see that I'm saying. Can you all see my screen? Okay, no, sorry. Let me share my screen. Let me share my screen so I can see. You can see those that have submitted. Okay. Can you all see my screen now?
Okay.
Can you all see my screen? Can you all see my screen now?
Yes, sir.
Yes, sir.
So I will scroll down now. Look at the test now. Can you see the test now? Can you see the test?
Yes.
I will click on the test now. We see now that you can now see that hidden from students. I've hidden it. Now look at the test now. Look at the question. Look at the people that have submitted. Adeton Messi was able to submit. Rilwan Tayo submitted. Nasiru Salim submitted. Adeton, not all.
That's
I got all the questions. I was unable to submit all the questions.
Mohammed,
but I just said one just entered.
Submitted. Yusuf Adekunle. Okay. Anyway, 1, 2, 3, 4, 5, 6, 7. This 7 students will still get the bonus of 4 marks. They will get bonus of 4 marks. Sorry, serious.
Sir, hello, sir.
Hello.
Because I have to make sure that I submitted the assignment. I am still in church now with my people. We are delayed because of the rain. I told them to wait for me before going home because I had to submit the assignment. By the time I would finish, the rain started already. I'm still in church right now.
Don't worry now. I will make it available now so that all of you can see the test.
No, I mean I submitted already, but I'm just saying that because I have to.
You have submitted. Don't worry, you get the bonus mark. You get the bonus mark, okay? Thank you very much for that submission. So I will make it available now so that all of you can participate.
Hello, sir.
So, hello, I can hear you clearly.
Sir, what actually happened is that I use the stamp. I couldn't upload it. I do everything to upload it. I couldn't upload it. I don't know where to
submit. I've been already focused.
Okay, what will happen now is that please don't let us talk about the problem too much. Let's begin to talk about the solution. So I will make it available now to all of you. Then everybody should respond. Is that okay? Is that okay? So I'll make it available now. Everybody to participate. So one of these days I will call on you to design another method that we're going to use. Show now. So all the students can sit now. We can all sit now. So everybody should participate. So thank you very much for today's session. Thank you very much for participating. And as a matter of fact, I appreciate you guys. You are doing good. It's not easy. You know, I think I showed you my certificates recently now. That I am also an alumni of National Open. I graduated from National Open. So I know what it takes. So that's why I'm trying to use all this method. So thank you very much. So let's call it a day. So bye-bye, everyone. Bye-bye.
Thank you, sir. Bye-bye, sir.
Can I ask a question before you go?
Mr. Quadri, Akim, why do you frown your face?
The reason I told you something that I'm having problem with uploading.
Yeah, sorry about your problem. You cannot see. Sorry about your problem. You can go back now and submit.
Okay,
If you try your phone.
So I hope it's no longer hidden.
Don't worry, I will remove you from the WhatsApp group. So I will remove my judgment. So everybody should participate now. So let's all of us have, but those have submitted, they will get bonus. And those that are submitting now, you will not get any bonus. So thank you very much for participating. And I know it's very expensive, your data and everything. But at the same time, I would still like to appreciate everyone for joining me. So thank you very much. Let's call it a day. Bye-bye. Balogun Said.
Bye-bye, sir.
Balogun Said, let me see your face. Let me see your face. Do you want to frown your face like you are looking for ATM card? Let me see your face. Balogun Said.
No.
You are looking as if you are looking for ATM card. I bet.
No. I don't.
We are learning mathematics, so let's smile. Adeola Jikon, let me see your face.
Okay, sir.
Adeola Jikon, how are you?
I'm fine, sir.
And how was the test today?
No bad.
So everybody, please,
the solution
please don't forget. Question 1, you have to use voice note to respond to question 1. So I want to use your voice so that I can use that one to track you down, so that to avoid impact. University with you. So please, Francis Uchuku, let me see your face. Francis Uchuku, let me see your face.
Sir.
Francis Uchuku, let me see your face. How are you?
I'm fine, sir.
How was the test today?
It was fine, but I was on my way back from church, so I was unable to attempt the other ones, but I did only the oral part of it.
You know that we are meeting by 4 o'clock now.
I knew, but I actually cannot help you because we had a program in church that closed very late.
That's not tenable. That's not tenable. We are supposed to meet by 4. Anyway,
I'm so sorry. I'll do it now since the portal is over.
Yes, you can go back now. I believe you can all see my screen now. So I've made it available now. So please go back and respond to that.
How do we order one?
Okay. Thank you, sir.
Excuse, sir.
Hello, sir. Okay, yes, I can hear you clearly. Yes, speak.
I'm still insisting on the on that e-learning. How do I? In fact, I'm facing problems about this. The last time you gave us an assignment, the same thing happened.
Oh yeah, everybody. Look at my screen. Look at my screen. Let me show you an example. Can you all see my screen now? Yeah. Let me share. Can you see my screen now?
Yes, sir. Yes, sir.
Padre, so what you do is this. You click on the test. By the time you click on it, actually I've sent the link to you, so you don't need to click. Now look at it now. You click on add a new discussion. Can you see this?
Yes, sir.
Immediately you click, you see something like this. So what you now do is that you will make your assignment, you make it in terms of PDF. You can use Cam Scanner. So you come back here, link, look at this. Look at this. So you can click on look at it, insert or edit image, or perhaps you can make use of this. So, and I say that here you make your WhatsApp number to be the subject. So if you click on this now, link. Okay, it can ask you that browse repository. Then you can click on this. Then you choose your file. All together now. You just see the window, then you can upload.
Okay.
And if you don't like it, you can use Google Drive. Upload the assignment on Google Drive. Then send the link on Google Drive.
I've used the Cam Scanner, sir.
So please try to play with it. Please don't open it on your phone. If you open it on your phone, it may not go. So you can connect to one system, or perhaps that will help you.
I have done that. I've done that.
So please try to participate. So thank you very much. So let's call it a day.
Thank you very much, sir.
Bye-bye.
Bye-bye, sir.
Ola Deborah, let me see your face. Ola Deborah. Ola Deborah, let me see your face. How are you? Okay. Afolabi Gbemisola, hello, can you hear me? Afolabi Gbemisola, how are you? Okay.
Yes, I'm fine, sir.
Okay, greetings to you. So
yes, sir.
Let's call it a day. So bye-bye, everyone. Bye-bye.
All right, thank you, sir.
Bye-bye.
Bye-bye, sir.
Bye-bye.